we are going to start talking about shear and moment diagrams, but really this is part of what we talked about earlier with equilibrium. So the one thing that you got to remember with shear and moment diagrams is, in order to do shear and moment diagrams correctly, you have to do beam reactions correctly. So this goes back to earlier in the semester. So again, if you struggled with that, 7 weeks ago or whatever, go back to the chapter that dealt with equilibrium of structures, beams, and whatnot, and review all those examples, all those video links that we had, all the homework problems that we had. You can go back to the, whatever we did, go back in your notes and take a look at that and redo it again. You got to get the reactions correct. Okay? Why do we do shear and moment diagrams for beams? And actually we can do them for other things besides beams as well too. We can do it for anything that's subjected to shear and bending. But why do we do this? Well, we have a beam. It's got loads on it. Those loads cause the reaction. And again, back earlier in the semester, we found those reactions. But what else do we need to know? Well, ultimately, we would like to be able to design these beams. And beams are under two forces, basically, or two force effects, if you will. All right? Those forces in that beam cause a shearing force in that beam, and they cause a bending moment at various locations across the beam. Okay? And as we, in a week, next week, when we start talking about beam behavior, this will become more apparent what we're really talking about. But for right now, let's let it suffice to say, when a beam is loaded and you calculate the reactions, there's other things that are going on over the length of the beam. And the two primary things that we're interested in for design would be the shear force. How big is it at certain places? What's the maximum value? And also bending moment. How big is it? What's the maximum value? Where does it occur? The answers to these two things will help us design beams. They could be wood beams, they could be concrete beams, they could be steel beams, aluminum beams, plastic beams, whatever. But in order to properly design a beam, we need to know what the shear force is and how that varies across the beam, and also what the bending moment is. Okay? So that's sort of the introduction to shear and bending moment diagrams. The diagrams that we are going to create are just visual representations of the shear force on the beam. We're going to do a diagram for that. And then the bending moment on the beam. We'll do a separate diagram for that. What are these diagrams supposed to show us? Well, primarily they're going to show us the values of shear and then the values of moment across the whole beam. What we're probably most interested in most of the time would be the maximum value for each and where does it occur. I don't know if you've ever noticed this, but like when you're driving down the highway, you might look up at a steel overpass, steel beams that make up an overpass. Have you ever seen those steel beams and they might have big connection plates on them with a whole bunch of bolts on them? Well, that's one beam, but it's been spliced together in sections. They've constructed it in sections. And those big plates with all the bolts are called splice plates. Why do you think somebody says, hey, on that beam, let's place the splice plate at this point and at this point? You think there's any significance of what we're about ready to talk about? Yeah, there is. Okay? They're putting those splice plates in a place where they think bending moment's going to be very low or zero. Okay? Because those bolts are pretty good at taking shear, Those bolts probably aren't so good at taking bending moment. All right? So, I mean, there's a lot of stuff that, you might see in your day-to-day lives that, you might start to question, hey, I wonder why this happens here. Well, maybe the answer might be, well, that's because either the value of shear is high or low at that point, and the value for bending moment is high or low at that point. You ever go into, how many people are familiar with house construction or wood frame construction? Okay? You ever notice that, like on floor joists and whatnot, sometimes they have to drill through to put maybe plumbing pipes through a wood joist? You ever see that? Are they allowed to do that by code anywhere they want? It's actually governed by code where they can do it, okay? But it's one of those things. If you get into the building code on wood frame, like residential construction, it'll talk about floor joists and where you're allowed to cut holes. Well, guess what? Do you think you'd be able to put a hole in the bottom, of a joist, right in the middle of that joist? If the joist was 12 feet long, you think you're going to be able to drill a hole that's right at the bottom of that joist that's 6 feet out? No. Well, there's a reason why they won't let that happen, and it's got to do with bending moment. Where are they probably going to tell you you got to drill the holes? Yeah, probably towards the supports. There's a reason for that. Okay, so and we're going to learn the basics of what they're talking about here, and it's all relative to shear and bending moment on those beams.